Hello. Welcome, everybody. My name is Edgar Febres. I'll be presenting today a little bit about AI. I don't know if you've heard of it, but I'll try to explain a little bit about it today. Machine learning and high-value logs. I'm a senior platform engineer. I handle mostly the Splunk platform and the flow of log information through ET. So what do we want to accomplish today? Well, first thing would be to get to the next slide. All right. So like I said, we work at Enterprise Technology. I work with logs from the source all the way to the storage and compliance and policies on the information. I work on analysis, integration with third-party applications, with customers on how they want to use that data, and many other applications. We have databases, we have devices, we have the cloud information that comes through, in a whole bunch of stuff. We're going to talk a little bit about logs, metrics, and traces, how the information comes through, what is big data, and what is the data growth, and what we're looking at ASU, how the big data is being processed over here at ASU, what takes to process this much data, and what's the cost. How do we make it cost effective? We're going to talk a little bit about AI, ML, LLMs, and deep learning. The importance of being in the race, because this is a race, and the challenges and future of big data. So the three pillars of observability, that's where we're going to start. We have logs, which is anything that's machine generated from your network access point to your router, to the computer that we're using right now, to the connections that we're making with servers for authentication and exiting the university. Everything leaves a fingerprint, a footprint, basically. And those are basically the logs, the information that we go through. From there, we can capture metrics, and metrics is just a type of measurement of that reflects the health or the performance of any of these devices through the information. And then the other thing that we're looking at is traces. And traces are, it's basically the flow of information from the application requesting the information. So say, for instance, you go in and you log in, you go to a page, you type in, I want this information, and the page itself goes in and queries the information and then displays it, and then it animates stuff. So that flow from that request, from that click that you made, that's called a trace. It creates a trace of information all the way through until you get the results. So how much data are we working with right now? We have at ASU, we're handling about, let's say, where's it? This one doesn't say, but we're about 2.5 to 3.5 terabytes of data that we're handling every day that's going through. This is in the form of logs. We have in the platform about 350,000 ad hoc searches. These are people that come in and have a little script and go in and say, well, I want to know how many authentications or rejections have been in the last 20 minutes. That's a request. We run through those through maybe around 350 thousand every month. We process about 1 to 1.3 billion events every month. We get information from ASU, from Azure, from AWS, from Google Cloud, Just in this year, we've added about 133 users to the platform. We are running about 134 applications are built on this platform. There are scheduled searches, queries, and information that is stored for reporting purposes, for learning purposes, and we run about 1.2 million of those scheduled searches every month. We have about, almost 50 groups, roles, and different policies for each one of those that have visibility into each one of the types of data. We have right now installed on actual machines about 850 forwarding agents. These are pieces of software to just redirect the logs to our Splunk installation. And that Splunk installation right now runs in about 412 CPUs, of course, and power to process all this data. Is this big data? Well, we barely scratching the surface, honestly. We're not getting data from each one of the machines that connect to the internet. We're not collecting data from students' individual computers. We are connecting the data that flows through our networks, through our perimeters, through our firewalls that connect in services that we provide for the university in the cloud. So really, it's not enough. We don't have visibility into everything. It's very costly, and we are very selected on the type of information that goes through. About almost all big organizations are investing right now in big data and AI. Fortune 500. Over half of the businesses reported big data initiatives have good returns on the investment. So this is something that a lot of the industry is going to, and they're acquiring data and insights on that data. Just a few numbers here, 463 exabytes of data will be created globally each day in a couple of years. I think we're going to reach that number by 2024. Over half of the companies are adopting big data analytics. Over half of the organizations see customers and client satisfaction advantages from data analysis. But at the same time, we see that data breaches affect around 90% of companies, and that was in 2020. So, and another thing is that we lack the manpower to understand this data and to analyze this data, and that's very important. Approximately half of the data will be stored and decentralized into devices that will give you information and analysis. Now, right now, you can't think about it, but you see those cameras, the security cameras. Before, you had to install a whole bunch of security cameras that were connected to one main server, and then the main server did human detection and little things. Now the cameras themselves have enough power to get that information, and then what you're transmitting to the main computer is just the information that's relevant to those activities that are happening. So a lot of this data and processing will be decentralized. I can use several other examples like phones. For instance, we have a lot of information right now that's being processed on your phones, like the iPhone. There's a feature in there that uses machine learning to understand or to identify that you are the person talking to Siri. So you don't want everybody to just come in and impersonate you by just speaking English. They want to understand that it is you. So you go through a process of 25 questions. You let it rip overnight when the phone is charging, and applies the machine learning, and then now it knows it is you when you are talking to it. So these type of processes are being decentralized, and the power being spread around. How much does it take to process, this much data? This is our configuration right now. It's kind of an overview. We have about 12 index servers. We have storage, secondary storage that's stored on S3. We have heavy forwarders that filter information from databases, from HTTP events. We have deployers that send information to all of these machines. We have cluster managers that manage the flow information redundancy and readability, searchability of information inside these machines. We have clusters of search heads, which is where you land to query the information. All this is in ASU, Splunk forwarders, devices, net logs, heavy forwarders, just sending information. We get information from Azure, from Google Cloud, from databases, Amazon S3, everything that you can imagine that usually creates a log. We can pipe it through the Splunk system and do some analysis. But that's a lot of data. And it's a lot of data that, a lot of it we don't really need. There's some industry standards like network traffic. We don't need to know that, yes, you did connect every time that you connect and you're getting a positive for every event that happens. So we're looking at ways to reduce that data that's coming in, the tons of terabytes that are coming in, transform that data into meaningful streams of data, events that we're actually looking at. Maybe we're looking at the failures. Maybe we're looking at attempts from an IP that's foreign to the location that we're in. Maybe we're looking at the absence in a time period of certain events. So we apply filters, we apply sampling so that information can be segregated, leaned out, and then this is the information that we're going to start the processing and the analytics on. So that's very important, because if we try to move all the information as it's coming in, heck, we would run out of resources. And then every time that we're doing a search, we're looking for a needle in a haystack. It's just too much stuff. So we divide our haystack in little piles that are more manageable, that contain the information that we want. And that's the information that we're going to analyze, we're going to index, we're going to apply intelligence over. How do we make it cost effective? Like I said, these are the fundamental things. I mean, there are technical reasons why we need to slim down the data, get it to about 5-to-1 on the networking, getting about half on the Windows events, eliminating language that's repetitive, creating metrics instead of just events on the data coming in. But the key is matching these technologies with the real customer demands. Here's an example. I have a network administrator. It's been piping data through the system for a few years, tons of data. And I'm looking at the logs, I'm looking at his searches, I'm looking at the stuff that he's looking at when he's querying the database. And I asked him, hey, why do you keep your data that long? We need to keep it in there. You never know what's going to happen. Yeah, but you only search the last, week at most. So why do we keep it in this very expensive system? Yeah, well, we need the data. Well, how much of that data do you need? Do you need all the positives, or are you looking for when it gets disconnected, when you get an error? Well, that's what I'm usually searching for. Well, then I guess we can sample, all these terabytes and say we had, 300,000 of these events in the last 2 minutes. And that's the entry that's going to come in, instead of having the actual 200,000 or 300,000 events coming in through and then searching through them. That's the type of conversations that you need to have. You need to know, well, if you're searching the last minute or two, right? But you need to meet compliance from ISO, then can we move most of this information to an S3 bucket that will be cheaper to store? And if you'd really need to do an investigation, then we rehydrate, repopulate, re-index, and we look at that momentarily, temporarily. Yeah, that's a possibility. So matching those expectations with the data and applying the right the right technology and the right cost structure will help us out in the end and help everybody out. In data analysis, sampling is a must. Practice of analyzing a subset of data to uncover a meaningful information in a larger data set. Like I said, we just need to find the information that people are looking for. And sometimes we do reverse engineering. The data is already there. We're looking at who is doing the most searches and what they're searching for. And then we talk to them and say, if you really need this, it means that you don't need all that. If you don't need all that, let me get rid of it. You'll have it if you need it. And you'll go through the pain of looking at everything, but we just can't have it in there. That gives value to the information that we're picking to analyze. Data processing allows you to optimize your data pipeline for cost reduction, ensuring compliance, audit requirement, and enhancing operational technology. A lot of the information besides the sampling can be reduced, can be reconfigured, can be extracted on the transformation before it hits the bigger servers. What does that mean? Well, we usually have a few fields that are important, but sometimes we see in searches that people are actually looking for pieces of information that are part of the raw or the rest of the event that doesn't get indexed. So we try to do a transformation to pull that information and make it part of the index so that it's easier and faster to locate instead of having it in the general pool of information. Think of it as that information and it has a label, right? And the more detailed that label is, the better you'll be able to go into a particular bucket and pick up the bucket that you need to get the information that you're looking for. So transformations, indexing, and field extraction is important again. To deeply understand your customers, map the ecosystem, articulate, and then figure out how AI and machine learning can help them figure things a lot faster. And that's the important thing. Because now that we've determined that there's too much information there, and also that there's not enough information coming in, and that we've slimmed down and transformed that data into something that's meaningful, then we enter the race. Before this, we're not even in the race. So what are the tools? What are the things that we need to use to get us and be part of the race? We need to know. We need to know how to formulate these queries. We need to understand how this structured query language is made, is created. One of the tools that will be implemented actually first quarter of next year is the Splunk AI Assistant. And if you need to ramp up and learn quickly how to create these queries, you can go in and do one of two things. You can put samples of queries as input. So you've seen samples, you search the internet, how are people looking for this? They have a query, and then you need to understand it. The assistant tells you step by step in plain English, what is it that each one of these steps is doing? So that's something for you to learn. And then the opposite is also true, where you say it in plain language. Look for Windows security events for failed logins or any login type by user and output time, host, and signature. So you type in that, you don't know how to write that in query, but then it breaks down the query that you need to apply, and it tells you what is doing what. Great to shorten the learning curve and get in the race. All the tools, and these are based on machine learning, is anomaly detection. So we have the data, we run the query, we get results. Now we try to figure out, okay, what in a time series, what's normal and what's not. So you use anomaly detection rules and machine learning rules to say, well, let's look at this. This is the norm, and Anything above the norm is an anomaly. And we train that model to identify those things, right? And to alert us and tell us, hey, anytime there's an anomaly here, let me know. I need to look at the data. We get, this many students at the beginning and end of the semester authenticating and logging into a particular system. We need to know if we're getting way more or if we're getting more in times where there's not that much activity with the model that we've created. So anomaly detection is machine learning that's looking for those things. There's let me go back to the anomaly detection. The opposite is also true. There's a lot of false positives, and there's applications or add-ons to detect outlier data. So let's say there's a cool case study about UNLV that had everything piping through Splunk, right? And students have this is about higher ed success. So they correlated the interactions that a student has with their learning tools and the results, the success and the grades, and how successful they were on graduation with those interactions that they have with the applications and the services that were available for them. So what they did was they counted, how many clicks, how many interactions a particular student for a particular career was doing within a class, right? So the more the students were interacting with the tools, the learning tools and other indicators, they were able to establish a relationship between that and the results of those interactions, the grades. And with that, they created a learning model, a machine learning model, where the correlations and the results were verifiable. And now you have a machine learning tool, an algorithm, they'll go in and detect for future classes the number of interactions. And if somebody falls below a threshold of interactions, then there's an alert here. Somebody is not interacting, more than likely they're going to fail. What can we do to intervene so that person, gets back on the bandwagon? Outlier detection would be, well, they don't interact in certain times of the year because it's a spring break, or they stop going to they stop going to the class because they don't want to take that class anymore. So those outliers go into secondary detections and say, well, this is normal. This happens on this time of the year. So those are outlier detections, and basically sifts out the sample and gets into meaningful information. We have something called the Machine Learning Toolkit installed on our servers. We have over here examples of how to apply machine learning in IT, in security, business analytics, Internet of Things. And with those examples, you have models that you can start applying to different cases and different industries. So they do the work, we apply the models into our data, and that's how we get value from these things. And it can go even further. Splunk has an application for data science and deep learning. And it basically, I don't know if you've seen some of the sessions that talk a little bit about deep learning and large language models, but it gives you the tools with all the data that you have to configure, set up the Docker and the images and the clusters to start crunching all those numbers that you're sending to it. So it does a little bit of orchestration, it does a little bit of content management, and then it pulls those models or those algorithms in to be used with real data. This is part of the Tensor board. There are many more things that you could do with machine learning and security applications. Not going to go over those. They're just different tools that have been industry standard models that you can apply to the data that you already have. So you have a ton of people already working on those models. You just pick them up and find the applications with your data. Cybersecurity, cover that. This is the Splunk cases in higher education. Let's see here. Yeah. So the process can go through, selecting the right data input, training the engagement models to look at certain pieces of information, train and create the predictive models on time series of how things usually, what happens. You train those predictive models in the modules. You test those modules with real data. Once you have it identified with a particular sample of data, you apply it to other samples and you verify. Once you have a consistent algorithm that's been created with machine learning within the application, then you can start applying it to other samples of data. And then you visualize the results, and there's a ton of tools for visualization. It can also interact with Alteryx and other tool sets for visualizing the information. We have an API that you can communicate with and integrate. So all this data is interchangeable. You can crunch a lot of the information in Splunk, send it out, create reports, create dashboards, so on and so forth. So why be on the race? And why do I call this a race? A simple analogy or an example is, let's say security, right? We have a ton of data in security. We're doing searches manually. We're creating our own little alerts, right? What do you think that a cyber criminal is already doing? That they're not looking at AI, that they're not looking into ML, that they're not harnessing the potential of thousands of hacked devices to crunch new ways to get in and to not be detected. Whether we like it or not, we are in a race. If our university doesn't take good care of the data, doesn't analyze the data, other universities are going to do it. They're going to perform better. They're going to have better results with the information that they have. And that's why I call this, being part of a race. If you're not already using AI and machine learning to catch up to these actors or the competition, or in sports, or in anything that you're doing right now, then you're behind in the race. And we cannot have people doing what machines are now doing. So it's, you either use it as your part of your tool set and be part of the race and be competitive, or you just fall behind. You cannot hire enough people to do the analytics, write each one of the pieces of searches and stuff, and try to look at graphics and little pictures and bar charts and anything like that fast enough to compete with people are using artificial intelligence and machine learning. It takes about 1% of compute cost to have the same results of one person doing an analysis. So once we have the training, once we have the data, once we program these algorithms, now we can compete at scale. We can grab more information. So when I was saying, well, we handle about 2 terabytes to 3.5 terabytes a day, and it seems a lot. It's really not enough. I mean, just on our Cloudflare firewall, we're handling 17 terabytes per day, and that's just external and certain things that are coming in and out. And we have a lot more information and points of data that could be coming in for us to analyze, but we just need to go through those steps and be competitive when doing so. That's wow, that's it. Yeah. So I cut a lot of the stuff that I had. I can go deeper into the different things that we're doing, but basically, this is us. You can find us in the Splunk channel. You can also email at splunk@asu.edu. And in there, we can help you out with machine learning sample data that you want to throw in. I was just talking to the people from the analytics portal, and we're going to try to bring those tools and make them part of the analytics portal so that people have access or at least exposure to the tools that we're using. We are refining, but expanding. We are being a little bit more selective about the type of data and the time it takes to retain that data and the type of things that we need to look at in the data. So we're always welcoming new data sources, new ideas, new analysis for our platform. So that's it. If you have any questions, yeah, Rob.
What have you seen and what do you recommend to do to get that data out of those applications?
Well, yeah. Fortunately, there are a lot of integrations within Splunk as a company with third-party platforms, integrations like with ServiceNow, with Salesforce, and we have APIs in our system and applications that you could just download from like Splunk Base and stuff like that will interact with those third-party systems to extract information. Unfortunately, we can only get what they allow us to get. But a lot of the information that's accessible in those platforms and in the SaaS can be accessed through APIs. So if you have information that can be accessed through an API through a Node DBC connection, then we have the connectors to those and we can extract data. And then with that, we can join it and make it more meaningful. One example is CrowdStrike or all the endpoint and email services that we have. If you're somebody that works in the security arena, you would need the keys to each one of those services to be able to get the information from them and then put them in one place that you know how to use, that you have the tools. Well, we interact with CrowdStrike for detection and infections on machines. We interact with email. So it detects spam, phishing content, and so on and so forth. Now, instead of having to go into each one of those systems, we're pulling information and we can correlate information or make sense by using inference in between, say the IP, and then, this person got an email and that email made him go to this website, and from this website, they downloaded this piece of software. Well, CrowdStrike detected it, and then now we can do an investigation and go back and determine that it was this person from this IP, and then where else did they go? Oh, they got an email that came from this service. Now we can start blocking all those things. But those tie-ins and those ways to have all the information there and be able to tie it, that's where a lot of the machine learning comes in. But yes, to go back to your question, there are many ways to get information, but we can only get as much information as they will allow. So APIs, I know that we already have access to a lot of those APIs. A lot of it can be written and scripted to pull information and interact with. So within Splunk, you can create applications that use tokens and APIs to connect to other systems and pull the information that you need. And then that information can be saved on a KV store, on a CSV, on local storage to interact with other points of information, other sources of information. Yeah, thank you. Any other questions? Yeah. Okay, so very good question is how to categorize the data that's coming in, how to use the metadata that's coming in from those sources. A lot of this is already done for us. If we have sources like Cisco or Aventry or Canvas, there are applications that will pull that information, index or extract the fields that are important, more relevant from that information. But the cool thing about it is that you can go even further, because if you're pulling information, say from Shibboleth, and we had that case recently, it pulled like four fields right away. We updated the add-on for Shibboleth, and then there was one field that the identity team was always looking for that was part of the raw content or the data that's coming in that's not being indexed. We were able to do an extraction, and then that extraction was able to be indexed. And now the reports are coming in way faster because it's not looking for just three things. It can find the fourth thing in the label instead of going into the bucket to retrieve it. That can be done in several ways. It can be done at the analysis, can be done on the fly, can be done before it hits the index servers with transformation. That's what some of these heavy forwarders are really good at, is processing and transforming the information for the stuff that you need. But that's why it's very important to communicate with a customer and ask them, what is it that you're looking for in this piece of data? What are the stuff that you never look at, And then from there, make the decisions on what information we're going to sample and just get metrics from, and what information is relevant to the queries, and then make that information part of the label, make that part of the metadata that it's available. So yeah, most of it is already pre-packaged for us. We can go in and customize, and we can do a full transformation before it hits the servers. Now, something cool that happens, that's happening right now, it's that a lot of this data, for compliance reasons, we need to keep it. We get an audit, we need to have everything that's in there. We can intercept that data before it hits the servers and say, well, save everything over here to freeze it on, S3, create a rule that, if it's over a year, just delete it. And then the subset of that data, the one that's sampled, the one that's field extracted, the one that's simplified, the one that is transformed to fit a SIM model for security, or a SIM for observability, or anything like that, that goes in to our system. And since our users are only using it to retrieve the last week or two, let's keep it for a month in the very expensive storage, and the rest goes into Smart Store and S3 for 6 months. And then if you need it after that, hey, you can retrieve it again up to a year from directly from S3. So that's how you manage. Each of these buckets has policies on how much time you're going to retain it for. The data that's inside those buckets are called source types. And those source types, like for authentication, for connectivity, for different things, have different characteristics, and you transform those to meet certain criteria. But yes, multiple ways of doing that, and getting better value out of the information that you're bringing into the system. Any more questions? Yeah, Jason.
The anomaly detection, are there people for alerts that are in place
now systems that detect or intrusion detection.
Yeah, let me give you an example, a very custom example. We recently moved our SOC, the SOC team from a remote location to in-house. Then with that, we got a set of tools, a set of queries. We also got an add-on to Splunk called Security Essentials, and basically, it shows you and it teaches you how to identify or create detections, and it gives you examples of those. So the SOC team has been grabbing those examples, applying it to the sources that we have, running it through a cron schedule, a schedule every 3 hours, 4 hours, and if anything, if you get any results from it, if the results are more than one for a particular error or a particular set of parameters, let's say fail connections from a foreign IP, right? Or they're trying to use all these users from the same IP to authenticate, right? Those are the detections that are built in. They're running every so often. That's part of the 1.2 million scheduled searches that run every month. If that happens, then it generates a ticket. It's integrated with ServiceNow. It generates a file, a CSV file that's being saved on an S3 bucket that's being monitored by High-Tech. And High-Tech picks up that IP from the block list and applies a block rule to the perimeter firewall and says, do not allow any more traffic from this guy or from this IP. So that's an example of an alert that runs and that does multiple things. But yeah. I didn't show the graphic tools and all the analysis tools, but hit me at Splunk in the Splunk channel. Email me at splunk@asu.edu. And we can open up a conversation. If you have a case study, I'll be glad to help you out. And if you have data, bring it on. All right, guys. Thank you.